Alright, so in this video I'm going to show you how to replace cells in Porter Cable generic and name brand batteries. And this is kind of an addendum in the middle of the video because I went through this whole process of building a DIY spot welder, and there's my welding cables up there, and it failed horribly and ended up buying this battery powered one. So if there's inconsistency in the footage, it's just that's the way I work normally, but also because this video got partially scrapped in the process. So anyway, without further ado, I'm going to go back into the original intro of this right here, and then I'm going to transition over to approaching this from the not so DIY way. Okie dokie. Today we're going on an adventure to see if I can repair these two damaged Porter Cable 20 volt lithium battery packs. So my dad picked up this drill and impact gun set along with these two batteries probably like 7 years ago, 8 years ago, something like that. And it's been real faithful for me ever since. I mean, I think I've almost broken the drill maybe 3 times, but it's still kicking. And this battery pack still works like a champ, but this one has died pretty much immediately after we got it. And additionally, we have some of these cheap Chinese knockoff ones, and this one is damaged. I have another one that's still working. The problem is that these things only have just barely enough charge. They last for maybe like, using the drill or something, like 2 minutes. If you put it on an angle grinder, you get like 30 seconds out of it. They just don't have the oomph. And that's because they have a dead cell. And the way that I can tell that these are dead is, one, you put them on the charger, and I'll show you what it does. Now, if you take one of these guys and you stick it on the charger, you see it's green at the start. And then shortly thereafter, it switches to fast blinking red. See, there you go. Fast blinking red means damaged battery. The other one does the same. See? Now, the thing is, that doesn't necessarily mean that they're dead. Additionally, they still work. But they're weak. They don't have a lot of power. And what that means is that there's probably one dead cell in here, because these are just a stack of 5 rechargeable lithium-ion 18650 cells wired in series. And with these larger 4 amp hour batteries, it's 2 stacks of 5 wired, each stack in series wired in parallel, that gives you the extra amperage. However, just because your charger says that the battery packs are damaged doesn't actually mean that they have a bad cell. What could actually be the case is that these have been discharged so far that it is now beyond the minimum threshold of the charger, and it looks like it has a bad cell and the charger won't charge it. In that case, what you can actually do is hook up one of these to a good battery pack, and you wire it basically like you're jump starting a car battery. You wire positive to positive, negative to negative, with some heavy gauge, probably 14 gauge solid core copper would fit in there, or you can take 12 gauge solid core and just hammer the ends flat to make them kind of like this shape, and you can jam those in there like that. Let it sit for a couple minutes, and that'll allow the two battery packs to equalize. So if you have a fully charged 20 volt, and let's say this one was hooked up to something that drew it down to, I don't know, like 13 volts or something like that, this will equalize the two of them to like 16.5 each, and that still may not be that still may be below the threshold that this will register, but you can just try that with a couple of batteries and you can eventually get it all equalized out. And if the battery pack is good, then you can hook it up to the charger. However, if you have a bad cell in one of those batteries and you do that, these are lithium ion, and it could explode and it could catch fire. So I would strongly recommend not doing this any place that catches fire, like a house or your shop or something like that. And additionally, I would highly recommend opening these up and testing the cells individually with a voltmeter before you try that, because it only takes about 5 minutes as long as you have the right bits, and it's definitely better than accidentally blowing up your good battery. So anywho, in order to actually truly test to see whether you have a dead cell in one of these, what you have to do is open up the case. And on these guys, it is a T10 safety Torx, just 4 of them the whole way around. On these big Chinese ones, it's kind of a pain to get down in there. You really need like a torque wrench or a Torx like key or Torx like driver with a straight shaft or a really small adapter or a really long bit or something like that, because most 1/4 inch hex adapters won't fit in this channel. I was able to do it with a lot of trouble with mine, but with these smaller 1.5 amp hour batteries, way easier. It's just a simple process. So anywho, let me open this up and show you what I mean by testing cells. Okie dokie, so I've taken the two packs apart, just 4 T10 safety torques on either side. I don't know what it is about T10 safety torques, but it seems like every one I own is boogered. Anywho, before you actually take the packs apart, I forgot to do this, test your cell and just see what the voltage is. You can see right there, this guy's reading 16.65. On these Porter cables, it is far left is negative, far right is positive. When you're hooking it up, DC voltage on a voltmeter, it doesn't really matter with polarity. It'll tell you either way, but might as well just do it correctly or it'll read negative. As you can see, this one is also about 16.5. So, as you can see, like I said, these are 5-cell series stacks. And with the larger amp-hour, it's just another stack of 5. So these are supposed to be 20-volt packs, and as you can see, we're down exactly 20%, fully charged. These packs are supposed to read a little bit over 20, I think close to 21 volts. As you can see, fully charged cell reads a little over 25. You have to switch it to the 200 DC volt setting on your cheapo multimeter that is like a $10 Chinese one. But anywho, as you can see, we're down pretty much exactly 25% on the total voltage, which is highly indicative of a bad cell. If you're down exactly 1 increment of the number of cells in the whole system, generally means you got a bad cell, bad battery. It's the same if you're working with a golf cart or something like that, or if you're testing a car battery. If it's supposed to read 12.9 and it says 10.5, you're down one of the 6 cells. Same principle. So, once you open these guys up, what you need to do is check individually each one of these cells. Take your voltmeter, and I don't think I'm going to be able to do this one-handed, but just jam it into one side of the battery and then check the other side. As you can see, reading 4.1. So just go by and do that on all of your cells. On this one, it doesn't actually look like, there's no visible signs that anything is bad. These all look fine. But if you come over here to this one, really obvious that something has gone horribly wrong over here. And with these larger 4 amp hours, you do have to pull them up out of the case. Like that. It's fairly easy. These Chinese ones are not glued in. The Porter cable ones are glued in. You have to pry it up, but it's kind of like a multi-use glue. You can pull it up and then put it back down, and it'll stick again. It just won't stick as well. They're not really in there all that hard. These are like this is a 10-year-old battery, and this guy is holding up just fine. So really quite impressed with the quality of the cells that they used. But as you can see, definitely something going wrong with this stack. And with these multi-stack 4 amp hours, you want to check every cell, not just one set, because you could have one cell go bad in a stack like that, and it won't actually affect your voltage. You could have a battery that is bad, has a bad cell in it, and it won't actually show up as bad, but it'll have like half the capacity it's supposed to. It'll act like a 1.5 when it's supposed to be a 4. That'll be because you lose one of these cells out of there. But say the one on the other side in the bottom stack still works, so you'll only be using like half the battery. So if you've got one of these 4 amp hours and all of a sudden has just like lost half its capacity, probably have one dead cell, and it won't show up with the voltmeter just checking it from the front. You'll have to disassemble it and inspect all the cells manually. But when you find a dead cell, it'll read just straight 0 or like 0.1 volt. It'll be incredibly obvious. And luckily, you can fix these, but it's a little bit complicated. It's not just as easy as just like popping the battery out and soldering a new one, because you have to spot weld it. So you have to have a spot welder, and I think I'm going to show you how to build one real quick. And if you don't have, if you work on small engines, like if you repair like riding lawnmowers for a living, you should be able to build a spot welder for $0. You should have all the spare parts lying around or in inventory. You should be able to do this like that in like 30 minutes. If you don't, I'd recommend just going on Amazon, and you can buy like a little $50 battery powered spot welder, and that's probably your best bet, because if you want to buy all the parts new to build one yourself, it's going to cost more than just buying one of those. So I would just go that route. But I think I should have most everything lying around here in my garage that I can cobble one together. So I think I'm going to try and build my own and see how that works, because I should only have to do this, once every 5-10 years or something like that. But anywho, before we get to that, you're going to want to figure out what kind of batteries are in your packs. If you're lucky, when you turn these over, you should have one of these battery packs with all of the labeling on it, and you should be able to figure out the battery, search it up on Google, go find it on like Alibaba or eBay or something like that, and buy some replacement cells. You want to go with the same style or the exact same manufacturer and capacity cell that you have in there. You want to go with the same capacity or higher, if at all possible, and you want to go with the same manufacturer. With these cheap Chinese cells, it doesn't really matter. With the name brand Porter cable, these are a Sanyo / Panasonic. So you kind of want to go with a high-end one on here. But if you get something that's cheap and Chinese and has a higher capacity, you're probably fine. It's better than having a dead battery, but you don't want to do something wildly different. You definitely don't want to go under, because you'll limit your capacity, and if you go under the capacity, it could catch fire and explode on the charger. But if you go just a little bit higher, like don't go crazy, don't get like triple or something, but if you're in like 25%, you should be fine. I'd also recommend ordering like twice as many as you think you need, because probably once you start using these again, one of the other cells is going to fail. So it'd be good to just have them in storage as a backup, so that you can do this repair again if another one fails, and you don't have to go through and order everything and all that jazz. With these guys, an easy way to figure out your the amp hourage, like the minimum amp hourage of your battery, is to just look at the amp hourage of your pack. This is a 4 amp hour, so since this is a double stack, you half that, so these are 2 amp hour batteries, so 2000 milliamp hour each. Since they're wired in series, they all have the same amperage. So if you have a 2000 milliamp hour 18650 lithium ion, that should be a sufficient replacement. However, I don't know if that is the exact rating. This might have some sort of like the rating that the manufacturer puts on it compared to the rating of the actual battery pack might be different. These might have a reserve capacity that they don't draw from, so you may need to get actually like double or triple what it actually says. If your battery actually states a milliamp hourage on it, good, you're awesome. Both of mine, from what I can tell, don't. I really got to look at that one better and this one better. I may actually have to pull one of these cells to be able to figure it out. But yeah, try and go with a direct replacement if possible. If not, get something that has at bare minimum the same amount of milliamp hour rating, and is at least an equivalent quality battery manufacturer. And if you can't get the same milliamp hourage, go a little bit higher, like 25%, or like stay within 25%. Don't go too high, or the charger will try and keep charging that, and it'll overcharge the other cells, and it could blow up. Just keep it in that same range. That's all I'm trying to say. I don't know how well you can read that, but that is the Sanyo battery that is in the OEM Porter cable. See right there, Sanyo. I looked these up last night. They don't make them anymore, so have to get something equivalent. I'm assuming that 21111 is the milliamp hour rating, because I can't find any specs on these. I have to research some more. I'll report back if I can find actual specs on these things. This is a 1.5 milliamp hour pack, so at minimum these are 1500 milliamp hour batteries, probably higher because they probably have a reserve capacity in them so that they don't like die, because lithium ion batteries don't like being drawn down to empty. So yeah, these are, I don't know whether they spec off of the full capacity of the batteries or off of their reserve capacity. Probably the full capacity of the batteries, because that's better for marketing. Anywho, also, word of caution, these guys right here, these are hot, and when you don't have the protective coating on there, don't put it face down on an aluminum workbench while you're trying to film, because they did just short out on me. So just FYI, word of caution, and like don't just like put your hand on those, because those are live. What you're going to have to do is you're going to have to order up some new cells, and you're going to have to replace these. And these guys are spot welded, and you're not going to be able to just solder these on unless you're like a professional, like electrical engineer, and you solder for a living. Then you're on your own. You figure that out. You know more than what I'm. You know more than what I'm doing right here. I don't know why you're watching this. You can figure this out yourself. But you don't want to solder onto lithium-ion batteries, because if you put too much heat into these, they can explode and shoot like boiling hot caustic gases and fire into your eyeball while you're trying to solder, while you're like this, hunched over it like that, and like straighten your eye. So don't do that, and then burn your house down. So you're gonna have to spot weld, and that's what these little guys are in here. So yeah, that's why you need a spot welder. So I'm going to attempt to build one. I may not do that. I may not actually have the parts lying around, but I think I should have enough that I can order up the few straggling parts I have and still end up less than buying a battery powered one. Additionally, there's some other videos out there on the internet showing how to build a spot welder, and I'm just plagiarizing them and improving it slightly, so you can go look at them. But probably your best bet is just buy a $50 spot welder off Amazon. If you've got a $50 battery that's dead, probably not worth it trying to repair it, but if you're like me and you have two, and you already have the parts laying around to build a spot welder, it's worth the investment. Plus, if any of these other ones, I have like 6 of these batteries, if any of them ever go, it'll allow me to, repair them when those go. And yeah, so simple as. The trick with spot welds though is you have to break them off. You can't like desolder them. You can't just heat them up and pop them off. So you will have to get in here with like a screwdriver or knife or something and break these welds, and try not to break your tin. If you're lucky, you can just pop both spot welds off out of either side, and then just slide a new thing in and spot weld it, and you don't have to detin, desolder any of this stuff. But you may want to just like desolder one of these wires just so that you don't short stuff out while you're working on it, just as a safety thing. Okay, so to circle back to a bit, earlier I was talking about if you had a battery that was just really discharged and it was below the minimum threshold for your charger to, detect that it's not bad and that it needs to be charged. What you can do is equalize it with a good battery. If you're like really discharged, you're probably going to need to equalize it with a couple of batteries, or you'll have to do it very briefly with a good battery, pull it off, charge the good battery, and keep doing that until you get it up to the right amount. And this same sort of principle works with if you have a car battery that's really discharged and you have a charger that won't recognize it because it's below the threshold. You can hook up 2 car batteries in parallel and then charge the good one, and the good one will charge the bad one while it's being charged. You don't want to leave the good one on there too long because it will get overcharged, because the charger will just see it needs amps and it'll pump amps into both at the same time. And you can boil a car battery doing that, and you can blow up one of these doing that if you were to say like hot wire these 2 together and then hot wire it into the charger. So I wouldn't recommend doing that. But anywho, if you go in here and you check and then like all 5 of your cells are still good, but they all read like 2.5 or something like that, and it's just really low, what you can do is take I believe this is 12 gauge copper solid core wire, and you just take one end and you just shove it into the positive, and then you get another wire, you shove it into the negative, and then you just go positive to positive, negative to negative. You want to use the thickest wire you can. If you want to be fancy, you can put some male spade connectors on the end of it, or like get some 10 gauge wire and hammer it flat and really jam it down in there. You want to keep them as short as you can, and again, you want to do this somewhere where you're not going to burn your house down, because if you do actually have a bad cell, it could cause it to overheat and just burst into flames. So don't do that. That's the trouble with lithium ion. But anywho, you just connect those up, let them sit for, someplace away from flammable things for, I don't know how long it would take, 5-10 minutes. Come back, pull it off, check the voltages of each, and once you get this one up to it's probably beyond 17 volts, because these are 16.5 and the charger doesn't like them. Actually, this guy's 16.5, and it'll start charging it, and then it'll detect that it's got a bad cell, and then it'll stop. So I think you need to get them over 16.5 in order for that to work. So yeah, you're going to want to have either multiple batteries, and you want to just equalize the 2 of them, and then you should be able to pop it onto the charger and then get it to charge. So if you have an overdrawn cell, that's how you recover it. But in my case, I definitely have bad cells. I've got two in here and 1 in here that are just completely shot. They read like, I think they both read like less than 1/100 of a volt. So I just have to go buy some new 18650s and spot weld them in. So I'm going to go research my cells and try and figure out some equivalents to replace them, because mine don't have milliamp hours printed on them, and figure out reserve capacities and stuff like that. And I will report back and let you know once I got batteries in. Okay, so all the spot welder stuff that I was going to do failed horribly. So I just went ahead and bought this cheapy one off Amazon. It's charging right now. But hopefully this should allow me, along with this new nickel solder strips, to solder in these cheapy generic Amazon batteries I bought which are just whatever I could get that was 200 milliamp hour approximately. I think these are even French manufactured because they're double pont. But anywho, I'm going to bust these guys open and see if I can bust some cells out, and I'm going to find something to test those on. Probably this NiCad Porter cable battery I have. Because it's a similar setup, but it's NiCad batteries, and this guy is totally junk, and it was actually far cheaper to just buy new NiCad generic batteries for that tool set than it was to actually, rebuild the manufacturer ones. So, okie dokie, so I popped this battery pack open again, and this middle one is our dead one. I've got that battery charged up to roughly the same amount as those. It's a higher capacity, but it's at a lower voltage. It's roughly the same. It's not rocket surgery. And I've got this guy charging, and I've tested it out a little bit with these NiCad cells in here. And it seems like I need to let the thing charge up all the way before I use it, and I need to use it at full power because the nickel strips on there are a lot thinner than these guys that I'm going to have to try and solder through. And it was just barely burning through there with just, 2 tick. Oh, it's up to 3 tick marks now. But at 2 tick mark, half charged, it was barely enough to go through there. It was doing just barely enough at max power. So we are going to let that thing juice up all the way before we do anything. But first, in the meantime, I'm going to break the tabs free off this middle one, and we're going to try and reuse these original tabs. And if not, then we're going to nickel strip between that and that, and call it good. So I'm going to get to that and wait on that, and hopefully we can get this spot welded together sturdy enough that when I use it with an impact gun over there, it doesn't just immediately bust all the spot welds free. So we can hope. Okay, well, I just ended up deciding to do it. I just wanted to test it at half, and this replacement battery I got was ever so slightly almost too big, but I just barely managed to get it to fit. And I was not able to spot weld through these original steel tabs. What I had to do is I took a piece of the nickel strip, folded over I had to peel the original tabs off of the old battery originally with needle nose pliers. I'd lift up just enough with the screwdriver that I could get the needle nose pliers in and peel it up. Trying to do it any other way was just not working, and I shorted out one of these batteries just a little bit, and let a little bit of smoke out. It scared the bejesus out of me. So anywho, I stopped doing that, but what I eventually had to do to spot weld this thing is I took a nickel strip, stuck it underneath. It was easiest to do on this negative one over here, and these things just spook me out because I know they can just explode at any second and burn my whole garage down. But I just basically spot welded the nickel strip to the negative side of the new battery, and then folded it over the top of the old tab, and then spot welded the bejesus out of it on the top. And I did the same on the other side because these spot welds out of this thing are not all that strong, so I just went with more is better, and then I left slack so that, if it flexes or twists or turns or something like that, it doesn't just immediately rip it off. And just like that, we have 20 volts through the thing, and it's not on fire yet, so that's a good first sign. We're going to hook it up to a drill and see if it bursts into flames. And then we'll throw it on the charger and also see if that bursts into flames. Okie dokie. Well, that's all back together, and you know the drill. Slide her on here, and not drop it on the floor, please. And that's doesn't tell you much other than that it's putting out 20 volts. But yeah, I mean, it's at the very least it's functioning as would be expected of a battery. Don't know how much longevity it's got in it or whether it's going to take a charge correctly. But we'll see. We'll have to do some slow charging, charge it for an hour and let it discharge, and charge it for an hour and let it discharge. Because that new battery I put in there does. It was lower than the rest of them, not by a crazy amount, just by a tenth of a volt. But I did not have a way to charge it up to the same capacity as the others because I put it in that charger over there and it said it was good. So I'm going to assume that it's good enough for now. But anyway, I think we will actually throw that on the charger right quick and just see if it gives me the old broken light blinks or if it'll just take her as is. Well, it made a hissing noise, and it just tells me it's full, so it doesn't feel on fire yet. Uh-oh. Now it's telling me it's busted. Well, that ain't good. Well, this brand new 20 volt, well, new 20 volt max battery reads 20.2, and that reads 20.1, and that reads 19.1. So I don't know what the charger is detecting off of this battery that tells it that it's bad. I guess it's that just one cell is slightly off than the other ones. It must have some sort of onboard sensor that detects, charge in between the different cells, and one's just off, and so it doesn't like it. So I guess I'll run the thing down and see if that allows me to charge it back up. I don't know, but that's kind of weird, and I really hope that does not screw me over long term. Well, I just ran the battery in the drill for about 30 seconds, and now it's taking it just fine, and it tells me it's fully charged. So I think it was just slightly overcharged in some way, shape, and form, and it didn't like it. But now it sees it as fully charged, so we'll see how long that lasts and whether or not it kicks it out as broken again. Still could be something funny going on with the fact that there are different milliamp hours ratings on those cells, and 4 of them are old, but we shall see. I'm going to call that a success for now, and we're going to move over to working on that guy. Alrighty, and there's the big generic battery done. Same story as before, just soldered it to the battery, then folded it over on the tabs. These tabs were a little bit thinner, a little bit easier to work with, but it was a bigger pain to get the batteries out. They were definitely junk. But anywho, that's been done. Let's throw that back together, huck it in the drill, and huck it in the charger and see if it works. Well, that's back together, and again, you know the drill. Hey, you did that one-handed this time. And let's do for a upside down. That's running with plenty of juice right there. And let's bust this off, huck it on the charger, and see if it actually takes some juice. Here, let's see what we get. Hey-oh, it's taking a charge. That's a good sign. So I guess I'm gonna try and charge these up all the way. That one's already charged, this one isn't. And just do a little bit of a longevity test. I'll try and use these two batteries, and we'll see if they burst into flames or not. So I'll try not to use them while I'm working on a fuel tank or anything, or in a sawdust pile or anything that's particularly flammable. But hopefully this all pans out, and these guys hold together, in which case I will have saved exactly as much money as it would have cost to just buy another two after buying the spot welder and everything. So only do this if you're doing batteries in bulk. That's the big thing I want to emphasize here is that sucker was like $50 and the batteries were like $20. So altogether that's $70. I think you can get one of these you think you can get generic batteries. I think you can get a set of two for like $70-$80, and at that rate just go for it, because you're not going to end up with a better product doing this at home. I'll be blunt with you, especially not with a tiny little spot welder like that. You're going to need something big that can actually spot weld those solid tabs. So anywho, I'm going to finish drinking my scotch, and I'm going to go to bed because I still got to go to work in the morning. It's like 10 o'clock at night. I'm not going to charge that overnight because it will probably blow up and burst into flames and burn the garage down. All right, it's the next morning. I put this guy on charge for about 5 minutes, and it'll stop here in a second, but it's now perfectly fully charged. At least that's what the charger's telling me. So that one took just fine, no problem. This guy, however, is still giving me the red blinky light of death. So we're going to do some long-term reliability testing on this, and by long-term I mean like I'm just going to use them for a weekend or two and just proactively use only these two batteries. And we'll drain them down and recharge them a couple times through a couple cycles, or I'll probably just hook this light on there and just have it run while I'm out at work, and just drain the battery down. And throw them back on the charger, and we'll see whether that guy charges up or not. It should. All the issues I've ever had with dead batteries, it gets to a certain point where one battery won't take enough charge and the charger will stop doing it. But it will charge up the rest of the batteries in the meantime. You just kind of have to fiddle with it. I'm hoping this guy just has a charge imbalance, and the onboard sensors on there are just picking that up. And I just need to drain it down far enough that it can charge back up and get them all back into an acceptable range. But that guy over there, that one's working just fine. I think it's because the milliamp hour rating of those cells in there is different than the ones in here, and those are just closer. But anyway, we'll see. I'll test it out, and we will report back. All right, so I've used these guys a little bit, and this one works just fine. The only trouble is when it gets fully charged, that guy shows that it's bad, but it is charging all the way. So right now it's fully charged. As you can see, it shows I have a bad battery. But if I drain this thing down, when I put it back on there, it charges it all the way up to 20 volts. Then it stops. So yeah, there's some kind of onboard software, either I'm assuming on there, as well as on there, and it's detecting some sort of imbalance in the voltage. I guess that's what those little wires are, crossing off the board to different parts of the battery stack, what they're doing, but it's somehow detecting that there's a bad cell in there, and it's not allowing it to get full charge. This guy is giving me trouble. At the moment, this is down to 19 volts. I've run it down about 1 volt, just using it with the light, and occasionally I can get it to charge for a couple minutes, but at the moment, it will charge for about 15 seconds, and well, now it's just going to tell me it's all the way done. But that guy's got 19 volts in. I just checked it. They're up. See, there it goes. It's very inconsistent. It'll tell me that the thing is. You see, it'll blink for like 15 seconds. Look, well, now it's just gonna make a liar of me. But anyway, it'll charge for a second, and then it'll give me the red blinky light. So I'm thinking that one cell is still dissimilarly charged. And this may be a chronic problem. I may have to replace that cell, because if you remember, I swapped in 2000 milliamp hour cells, and I think what was in there was like 1600-ish. So I think one battery is just not charging the same as the others, and it's detecting that, and it's throwing an error, so it's not actually allowing me to charge it because it thinks one of the cells is bad, when really one of the cells just has a greater capacity. So I don't know. I think I'm going to bust this guy open again, and I'm going to try and manually charge that one cell in there. So I've got that battery charger for 18650s, and I think I should be able to get some alligator clips on either side of the battery, and then solder a tab onto the charger, and then hook a clip to the negative side of the charger, and just charge that thing off of the wall charger, just with some leads, and get that to go all the way up to full charge. We'll see. And I'm hoping that if I can get that up to the same charge as the other cells, that guy will accept it, and I can get up to full charge, and I won't have to worry about this problem again. But I have a sneaking suspicion it's going to be a chronic problem. So matching your battery capacitance seems like it's an important thing to do. But anywho, I'm going to just keep trying these guys out and see what I can do, and I'm going to try and get in there and do that, and hopefully that works. Okie dokie. So I've been running and charging this thing, and it's not wanting to play, and I think it's because this center cell is exactly 0.1 volt lower than all the other ones. Everything else is 3.8, and this one's 3.7. So what I've done is taken this battery charger, and I've just hooked our alligator clips up to all the contacts in it, and I have then hooked that up to the battery, and I just have the voltmeter touching these leads in here to see if something is actually happening, and I'm hoping that I'm charging it. I'm really hoping that there's not some kind of like weird something going on in there where I have to actually lift that up on that with the spring to get it to charge. But at the moment, I'm hoping that this thing is actually charging that one specific cell that we replaced based off of where I've got these alligator clips hooked up. And yeah, this thing definitely does have an onboard like battery charge detector. Oh, it is charging. It just went up. I just saw, yep, there we are. Very slowly. It does indeed have an onboard charge detector because each one of these wires is hooked up to every single one of these batteries. So this thing can see the charge of every single battery, and it's detecting that something funny is going on between this new one that we replaced. So I'm going to attempt to charge this up to 3.8, and hopefully that should rectify the issue. I don't know how long this will take. It's already been on there for about a minute or two, and it doesn't really seem, it's gotten like 0.01. So yeah, may take a while. I'll go eat dinner and come back, and it'll be like 4 something, and we'll be fucked, and we'll have to do each one of these individually or something, but I don't know. This should hopefully rectify the issue. Okie dokie, that probably took an hour, I think. Maybe a little bit more. But yeah, it's finally up to 3.8, mostly. Kind of shut up. But I gotta go eat dinner now. So I'm gonna pull this guy off charge right quick. Should just be a boop. Just let that dirty dangle. And we'll cut this guy off, and we'll see if that normalizes at 3.8 or if it drops back down. If it drops back down, we'll charge it back up by the difference. And if that all works, we'll put it all back together, throw it on a charger, and see if that fixes the charger not liking it. Okie dokie, well that seems to have stabilized, so I'm going to slap it back together, slap it on the charger, and see if something magical happens. Alright, moment of truth. It should be just a little over, I think it should be at 19 volts. So, we'll charge. Ah, fuck. Well, now I don't know what to do, so we're just going to ignore it and say that it's done. Perfect. Problem solved. Alright, so I realized I didn't have a control, so I went and I grabbed an identical copy of each battery, and as you can plainly see, yeah, for whatever reason, it does not want to put the extra volt into this, and I do not know why. It's probably that onboard circuit board is probably picking some up that this guy doesn't care about. Or again, it's the amp hours, and so the voltage is doing some sort of weird something, but I feel like that shouldn't be that big of an issue. But for whatever reason, the onboard circuit board is being stinky, because yeah, it won't let me go above 19 volts. I can charge it back up to 19 volts, but I can't go above 19 volts, and it's probably because that one's the wrong milliamp hour rating. And I ain't buying any more cells, so we're going to call this good, because it did work on these cheapo ones. But did not work in the name brand, so I guess, okie dokie. So I've been using these guys off and on for about the last month, and it looks like this guy is now working basically brand new. It still does the little blinky red light when it's fully charged, but it charges all the way. This guy is still being a pain in the ass. It does not like that dissimilar cell that I put in there, so I'm probably going to have to pull that out and replace it if I ever want this to work. It's back to being about how it was. Hey, that guy actually just finished while I was talking. I don't think that's actually done though, so we're gonna tell it to go again. So actually it is done. We'll check the voltage on that. But this guy is back to being basically how it was when I had a dead cell. It charges to about 16 something volts, and then it gives up. And I know it'll take more unless I just suddenly lost a cell. That would be, a real pain in the ass. I still got one more lithium ion I can replace it with, but I drained her down to like 14 something volts using her with that light over there, which apparently doesn't shut off when you get below the cutoff for these things. I don't know if it has a cutoff, but yeah. That guy, not so great. Make sure you match the milliamp hours of your cells when you're replacing them, because apparently the internal voltage check does not like mismatched cells. So let's actually check the voltage of that real quick, just to see if this guy is fully charged, because I have actually used this a fair bit, and that thing said it was fully charged after it's only been like 5 minutes, so let's inspect that. Yeah, she's done. 20.1. Huh, I must have recharged it at some point and forgot about it. But yeah, this guy's working great. This guy, not so much. I did get it to come up to about 16. But it goes for, about same deal it was doing, about 10 seconds. And then it goes solid green. And then it switches to fast blinking red light. It did something weird to me yesterday where it went all the way, it stayed charged. And it would just tell me it was fully charged, but it only had 16 volts in it. It was really strange. So I just kind of have to, charge this thing incrementally. It's a real pain in the ass. I'm going to see if I can see, now it's doing it. No, it's just going to tell me it's fully charged, but if we check, it is not. Yeah, see, we're only 16 and a half, which is what it would read if it had a dead cell, sort of. Dead cell would be a little bit less than that, but still. I might pull it back open and double check it. If I don't, that's because it wasn't dead. Well, I'll be damned. The new cell is actually dead. Huh. Well, that sucks. See if I can get one of these to go. No, I can't. Can't do it one-handed, but all of these check out just fine, all the other 4, and the new one is dead now. And I can actually touch the lead to the battery itself on either side, and I get nothing. So it just died. It either did not like the spot welding, or it just, shit the bed, instantly. Well, that's crazy. Strange. I'm not going to put that other 2,000 milliamp hour I saved in here. I'm going to attempt to find whatever these were, 1650, 1500, whatever I said, to throw in here, because yeah, that's just sucks. All right, well, this has gone on long enough, and I'm done fooling with these things. So yeah, learn an important lesson. Don't try and build a spot welder unless you're doing something on an industrial scale and you need the amps. One of them little battery powered ones is perfectly fine. Yeah, if you're just doing one battery, just buy another battery. It's not worth it. I'm $70 in the hole at this point, and I'm up one Chinese battery and still down one Porter cable battery. Could have just bought another Chinese battery for that. Anyway, another important lesson is if you are going to replace the cells, match the milliamp hours, because as you can see here, if they don't match up, the internal voltage regulator on that circuit board will not let you charge it via the charger. So that's a massive pain in the ass, and that's a big headache. I'm going to try and see if I can get a replacement cell for that matches, but we're not covering that in this video. If you like this kind of stuff, I don't know why you would, but consider liking the video, comment, shame me for not following through with this and making poor decisions. And if you want to see more crap like this, you got to subscribe, so smash the big red button. And until next time, Tom out.